use my camera.
No, we have allowed to use the camera.
No. I do like my like office laptop.
Okay. You are going to host the session, na? Sir, actually yesterday one participant also was Mr. Prabhakaran.
Okay.
Okay. Yeah. So, sir, you have your PPT?
Yes, I have.
Okay, fine.
Ma'am, shall we
So,
start?
we will start at 10 sharp because, sir, we have given the time of 10 o'clock.
Okay, yeah.
Right,
Yeah,
sir?
sure. We can start at 10
Yeah,
itself.
yes, sir. 10 minutes, please. After 10 minutes, we'll start.
Yeah, no issues.
Right.
Yes, Kajol ma'am, it's visible. Okay,
Yep.
ma'am.
Yeah, good morning, all the participants. As you have heard, we are going to start at 10 a.m. sharp because we will be waiting for all the participants to join. Yeah, Anisha, we can start and you can stop the sound.
Okay, ma'am. Sure.
Okay.
Okay, ma'am.
Good morning, everyone. I welcome all the members
Just a minute,
of.
Kajal. Let her stop the sound.
Okay,
Done,
ma'am.
ma'am. Done.
Okay. Okay, carry on, Kajal.
Thank you, ma'am. Good morning, everyone. I welcome all the members of the academic fraternity present in the day 5 of the Faculty Development Program on New Age Technologies for Innovative Solutions. Today, we have with us Mr. Prabhakaran Chandran, Data Scientist, MU Sigma.
Please move the slide also.
Yes, ma'am. Mr. Prabhakaran Chandran is a data scientist with 2+ years experience working with 500 clients to solve their problems using the power of artificial intelligence and data science. As an avid learner, he is always looking for learning and experimentation opportunities and is passionate about upskilling himself and others. He has built an end-to-end machine learning pipeline to allocate the monthly budget for each construction project portfolio for a Japanese construction firm. He has also worked on a Bayesian network-based agent modeling framework to predict the consumption of soft drinks in USA. This Bayesian network was built based on consumer behavior, their preference, and impact of marketing events. As a part of his data science journey, he has been mentoring colleges and students and enabling them with data science and machine learning skills. We welcome you, sir. Before starting with the session, I would like to just make a small announcements. The attendance and feedback link will be shared in the Zoom chat box only. Towards the end of this session, the attendance link will be shared and will remain active only for 15 minutes. No calls or messages in this regard will be entertained. Also, I would request the YouTube live attendees to please log into the Zoom meeting. Now, I would request you, sir, to kindly share your PPT and start with the session.
Yeah, thank you.
You please remove your PPT, Kajal.
Yes, ma'am.
I will start sharing now. Is my screen visible?
Not yet, sir.
Sir, it is showing that you are sharing. It will come. Yeah, it is
Oh.
loading.
Okay, now?
Yeah, now we can see.
Okay. So good morning, everyone. Thanks for this wonderful opportunity, and like apologize for not being joined yesterday because I had an issue, a health issue yesterday, so I couldn't join. But anyhow, like I really like kind of like happy to see such a good crowd, and I would really like to deliver a good content, good knowledge to the academia people. So today the topic is, as we are supposed to discuss innovative like technologies for like good solutioning, right? So the topic for the day is accelerating applied research and development with BERT foundation models. So this session would really help people, those who are into, like, I could understand everyone is a faculty here, and those who are doing like their postdoctoral research or like doctoral research, PhD related things, or even like some sort of like projects in right? So this particular session will help the listeners or attendees to explore the foundation model space, which is a new AI paradigm. Whereas like we can develop more applications for the society, for the industries also. That is why like I particularly bring this topic to academia people, those who are like always always like position themselves in applied research and development. So the agenda for the day is the introduction to foundation learning, foundation models. And we'll be learning about like what is foundation model, and why are we calling that, and what can we build, like like what sort of application that we can develop, what sort of solution that we can provide to the like existing social problems or industrial problems. And another one is like transformer. So most of us are like, a few of the members would have known about this transformers. So transformers are a sort of breakthrough that happened in the in the year of 2018 in artificial intelligence paradigm. So this particular breakthrough has changed the momentum of AI development, AI research and development. And another one thing that we are going to see is like BERT-based foundation models, and the capabilities of foundation model and applications of foundation model, so that we can discuss like what kind of opportunities that we have in place, so that like we can move forward, and we can move forward and build some sort of like applications, or do some sort of research and publish them for like benefit, like for the benefit of individual, and also for the college, institution, or society that we are belongs to. So when I say foundation model, so foundation model is nothing but any model that is trained on large scale or broad data, that can be called as foundation model. Why we are calling that as a foundation model? Because let's imagine we have a foundation as in like a civil foundation, construction foundation. So we can build n number of any kind of buildings on top of that, right? If I have a proper foundation with the type of the foundation, I can build like a 2-story building or 10-story building, or I can build some single villa, or I can build some like some community hall, conventional store. Likewise, I can build n number of like constructions over there. The same way, if we have a strong model, we can build n number of, which is like we can adapt that model to build wide range of downstream tasks. So we need to concentrate this downstream task in order to proceed with the applied research and development in a country like India, where we have a lot of people, a lot of our PhD professors are there, and we can build like domain-specific, problem-centric solutions, which will help us in a lot of in multiple ways. So, like what kind of models are like trained on large scale and broad data? So far, we can take few examples. One is BERT, B-E-R-T, BERT, and we know this GPT also. This GPT is like it launched last year, 2020, and GPT-3 has launched last year. Like, and it was like a kind of breakthrough only, because like it can do whatever you are saying. Like, okay, I want to let's draw. For example, if you want to write a code, it will automatically write. Likewise, it has. If you want to write a poem like a Shakespeare, it will try to write. So likewise, we have we have a model we have a deep learning based architecture. That particular architectures are being trained on large scale data. Large scale data is like TBs of data, annotated data that has been collected from the wide resources, so that like we can do like versatile activities using that particular data. So once we have the pre-trained models, once we have the model which is trained on the broad data, we can use it for downstream task for our purpose. For example, if I want to like generate a question paper for physics exam, and if I want to evaluate the physics exam answer sheets, I can build a model where the model has already trained on large scale data set, so that I can use it for my downstream. Let's go with an example. Let's go with the discussion points. Like I will more like to discuss things rather than just putting text, right? So let's consider the scenario, like people are in like work from home, study from home situation. If let's imagine like we want to build some question answering or auto evaluation system. So auto evaluation system as like for a particular question that we have asked, how relevant the particular question has been provided by the student, right? If you want to evaluate that, your model, which is the deep learning model, should have the contextual understanding. Then only we can correlate, okay, what is being asked and what is being written. So for those kind of downstream task is nothing but the task or the application which is going to be used by the end user. It's like one particular task, a simple task. It can be like detecting the hate speech in Twitter, or classifying the author of a particular book, or classifying the tweets into ideology, whether it is left or right, or classifying the songs into whether it is folk or it's a classic or it's something like some Western. Likewise, we have a number of applications, right? We cannot train from the scratch. We all know like how these we all know like how these machine learning models are work. Like, because when we take any machine learning model, we need to train from the scratch. The same way, if we are considering a deep learning architecture, which is neural network architecture, that has to be trained from the scratch. But the problem is, we ourselves, like when we do some sort of research, we will not have enough computation power, right? Our laptops are like at max 16 GB RAM will be there, or even IV individual can afford like 1 GPUs per month. Our labs, like institutions labs, might give only limited amount of GPU access. So in that situation, we cannot expect to train from the scratch. That is why we are utilizing this power of foundation model. And in simple words, it's a pre-trained models, especially transformer-based models, so that if we have the idea about like how these transformer-based models are working, and if we know some vision about like, okay, this year I should build 1 or 2 applications using these foundation models, so that me or my institutions might be benefited. Like I can publish that paper, I can use it for like it's like up to us only deciding that. So there is a story behind this emergence of emergence and homogenization of artificial intelligence. So in the year of like 1960s, 1990s, when this machine learning emerged, like the new term, okay, machine learning, machine can learn, but actually it is how to find the pattern. The emergence is nothing but the behavior of the system. For example, if we take a machine learning, the behavior of the system is how to learn, how to find the pattern from that. Homogenization is nothing but it is a consolidation of methods for building a machine learning systems across wide range of application. Let's see like what is the difference between emergence and homogenization, because like these two things would require to find the solution or to understand the need of foundation models. For example, machine learning, we always we always worried about like how a task is performed, like how we can easily how a particular task, as in like classification or regression, can be performed from the examples. It is like about how only. Whereas in deep learning, we know how we already have the answer to, okay, if we want to perform this particular task, we know how to do that, which is like, okay, we can perform a regression or we can perform classification. So that is being answered in the machine learning paradigm itself. Whereas in deep learning, we still need to adapt to one particular behavior. Emergence means it's a kind of explicit behavior, like implicit behavior. So in deep learning, we are concentrating more on this high level features. It is not explicitly we are doing. The model itself is like doing sort of feature engineering and everything. That is how we are making the difference between conventional machine learning and the deep learning, right? In conventional machine learning, there will be like a lot of manual effort that we need to put on the feature engineering part of that. Whereas like that is a limited one. We cannot like go for like a machine translation with just a machine learning model, because that doesn't have that feature handling capability. That is why we are moving to this deep learning, where this deep learning is always concentrated about like the handling high level features implicitly. We don't need to do any sort of feature engineering and all. And I would request people to note it down, because like it will not be like it is not like a like statement kind of thing. So that from the first step itself, we will understand it won't happen. We ourselves has to like do our own research about whatever topics we have discussed, whatever new terms we have heard from this FDP program, so that professors can do your own research and plan accordingly. Okay, I found that I'm inclined towards computer vision application, and in computer vision application we have some sort of foundation model. Let's build some sort of like industry or society oriented downstream application and publish it. Likewise, I would recommend, or I would request people to proceed in that way. That will help everyone. So we were talking about this high level features and all, but even though if we are like concentrating on high level features in the deep learning models, one thing is like for each and every task we need to build individual models. If you just consider RNN, the RNN which is built for Shakespeare music generation cannot be used for symphony music generation, because like the feature understanding is very limited one. The understanding or functionality of the particular deep learning model is very limited one, limited to one particular space, right? That latent space is very limited. But in foundation model, like we can perform advanced functionalities, like understanding the context that is being given importance, that is actually emerged here. For example, if you have one, as I said before, if you have a foundation, you can build a number of application or a number of construction on top of that. The same way, if we have one particular foundation, that can help us to like generate a Shakespeare poem as well as symphonies tunes. The same way with the foundation model, we can use it for machine translation. At the same time, we can use it for some sort of like domain specific applications. That is why so the thing is, the industry is moving 1x or 2x rate, but we people, those who are practitioners, not only academia people, even in industry people, they're not ready to bring these kind of technologies or these kind of advancements to the use cases, which is applied research. The research is happening and papers are published, but that are just a foundational base. They are not concentrating more on like the end user centric or industry problem centric or social problem centric applications. That is why like today we have taken this topic, let's build something cool out of foundation models. So this is emergence in artificial intelligence, how new things, how explicit, how behavioral aspects has changed from machine learning to foundation learning. This is one thing. And another one thing is how broader applications or how broader activities that we are able to cover nowadays. So during the time of machine learning and all, like we homogenizes just a learning algorithm. Okay, this is logistic regression. Wherever we need logistic regression, we can use it. It is just as I said, like it's just algorithm centric. Okay, logistic regression can be used in multiple ways. Whereas in deep learning, rather than algorithm, the architectures, model architectures covers most of the problems. For example, a convolutional neural network can help in biomedical problem as well as it can help in some sort of IoT related or manufacturing related or self-service, self-driving car related problems. So where in machine learning algorithms covers covered the application range, whereas in deep learning the architecture covers, because like here in our deep learning the algorithm seems to be same. Algorithm is back propagation only, like how things are being learned, like forward propagation, and from the errors the error will be calculated. Error will be calculated. From the error, gradient will be calculated. Gradient will be propagated, right? But that is common for all the architectures, where the model architecture, one single model architecture can be used for multiple applications. And after that, but the thing is multiple application as in like everything will be same, but at different domains. For example, image CNN, which is convolutional neural network, can be used for image classification task. But that image classification task can come from manufacturing sector, where we do quality assessment, or it can come from healthcare, where we do diagnose COVID X-rays, and it can come from some sort of like process industries, or some sort of even like real-time traffic signals, like this we can use, right? And where in foundation models, it homogenizes the model itself. Model as in like one particular model. Instead of an architecture, we are going to consider only one particular trained model, so that that particular model can be applied for a number of applications. So here we are covering the training aspect. So machine learning won't cover the architecture aspects, but in deep learning we cover learning aspects and architecture aspects also. But in foundation learning, we're covering that training itself. Like okay, we have trained, we have the learned parameters. Okay, this is going to be the dictionary, or this is going to be the reference for it. Using this, we can extend the applications. That is what like homogenization, which is like extending the application range or functionalities. And yeah, so this foundation models. So this small story, it all started by the end of 2018. Like as I said, like that the story of the transformers. So this happened in like NLP, natural language processing, in the year 2018. Google Brain team has published the paper Transformer. So that transformer, so under the topic of attention is all we need, they published that transformer logic, transformer architecture. So everyone started like inspired from that transformer architecture, so that like they started building their own flavors. So this particular paradigm shift, this particular breakthrough, impacted the growth of NLP industry. Because if 2018, if Transformers was not published at that time, we wouldn't have reached this much growth in the AI and even in NLP, because NLP, this 2018 is the like turning point. The foundation models are enabled by transfer learning and scaling them, because transfer learning is nothing but like utilizing the pre-trained one and building something on top of that. Because we can, as I said before, we cannot like train from the scratch. So that is what transfer learning, the idea of transfer learning is to take the knowledge. For example, I'm a pre-trained one, because like I worked in industry problems, I know something. So I'm a pre-trained one, I have a knowledge, right? But people, those who have participated in this program, are students, those who are attending my program, are not learning things from the scratch. They are like, then no need to do exploration from the scratch. I'm just directly sharing the knowledge. I'm directly giving, okay, you can study this, you can practice in this way through this faculty development programs, through webinars. Nearly I would have done like 20 plus webinars. So everywhere we're just sharing this knowledge, right? The same way in transfer learning, the pre-trained model is transferring its learning, so that like with that knowledge we can build some sort of like specific application. For example, people, those who have prior knowledge in AI, computer vision and all, there is a term called ImageNet. So ImageNet competition is the one of the breakthrough that happened in mid 2010, I guess, like 2010, 2011 time. So they launched some lakhs of images and thousands of classes. They asked people to build a model, whereas that model can be used for other applications. For example, that lakhs of images are there and thousands of classes are there. This scenario we will not come across in any time soon in the real-time applications. For example, in real-time application, we are doing some sort of like a traffic signal classification, if we're doing some sort of like a crop disease, or even like it could be like the industry specific one. So in those places, 1,000 classes wouldn't be there. So we already have an extended learning of ImageNet classification competition. So we can use that particular models and we can build for our particular approach. That is what, like within deep learning, pre-training is a dominant approach. A model is trained on a surrogate task. A surrogate task is nothing but an intermediate task in which like we will be having like broader data. And after that, we can adapt that to a downstream task. We are fine tuning. Actually, the two terms, one is pre-training and another one is fine tuning. Pre-training will be done by huge research and development institutes like Google AI, Facebook AI Research, OpenAI from Tesla Group, Microsoft. Likewise, like even like these are companies, these are tech firms, and like research and development centers of Western universities, foreign universities like Stanford, Berkeley, Oxford. These people are actually doing creating these kind of architectures and building these kind of pre-trained models. And our intention, like the people, those who are in applied research side, because like they will not solve the exact industry problem, they will just give the surrogate idea. We need to bring that idea, and we always have the subject matter. If you are working in a mechanical department, you would know what is, how can we understand the CAD images, how can we understand the additive manufacturing. Are like people those who are working in chemical engineering, are people those who are working in cybersecurity, they will know the understanding about, they will have the understanding about the subject, like how this malpractices are done, like how these attacks are being monitored, or how a new alloy is being formed. Like this, like a lot of things people will know. But we need to simplify that using the power of the pre-trained one. So that is why I'm like taking this. I'm insisting that. So what are the enablers of foundation models? So far, I've talked about like like foundation models. You would have like gotten that understanding about. Okay, this is what foundation model. The pre-trained one is for foundation model. Like we'll be having that understanding. But what is actually enabling that? What makes this as easier as possible? Thing is, like there are three important things that we can concentrate. One is the improvements in computer hardware, because in the years of like people, those who are like, I know like here we have people with the 20 plus years experience or 15 plus experience. In the like in the end of 1990s and in the beginning of 2000s, the millennium, so we didn't have that much computation power, right? Even like till like the year like 2014, 15, and that, like we were just using, like most of researchers were using CPU based computation only. But after that, this GPU, which is graphical processing unit, got started, democratized with people, and that is like started available to everyone. So nowadays we are in 2021. Anyone can go to Google Colab, or anyone can use Kaggle, where we are easily get to access with like 12 GBs or 25 GBs of GPU, which has increased the throughput and memory. It's like 10x, 10 times in the last 4 years. The reason behind is the breakthrough that happened in NLP, and the breakthrough that happened in computer vision, which started in the mid of like 2012, 13, and which reached the peak 2018, 19, and all. So this is one thing, like the availability of computer hardware. Still, we like in industry, we are like always like nowadays we are always like looking forward to work with the GPU only, because like that has a lot of power. That is actually like solving the pain points of the industry solutioning. Because like we can easily train the model in a quicker time, like in a very for example, if one particular training is taking a 10 hours of training, the GPU can do that in like 2.5 hours. I personally have faced this. And another one thing is like the development of transformer model architecture that leverages the parallelism of the hardware to train much more expensive models than before. Because previously, like before 2018 and that, we have only one model and we have only one objective. But after this transformer, it has become like multiple objectives, multiple type of data points, and parallelism also become possible for us because of the available hardware and because of the network structure itself. You can split one particular architecture, or you can train it on multiple instances. So this parallelism and the transformer model architecture is another key to success. And another one is like the availability of more training data. Nowadays, companies are like they are interested in investing more in data collection rather than just concentrating on running something. For example, tomorrow one among us may start working on a particular project, where if that particular project demands a new set of data, our duty is to collect that particular data points. Because nowadays AI, artificial intelligence, is like it has to be concentrated more on, it has to be like concentrated like more on data side also. Because like whoever learning machine learning, or whoever getting into artificial intelligence, the one common mistake that we are doing is like we are just running behind the architecture, we are just running behind the code. Actually, we should give the common like equal importance to the data also, because data is the fuel, right? If the fuel is corrupted, we cannot do any sort of downstream task. So that concentration of data should be given. And nowadays, like availability of data is high. A lot of research companies are disclosing their like their data. Even I myself has collected some sort of literature data, and we are proceeding with we are writing the paper right now. So it is about regional literature. So we were curious about like Tamil linguistics. We were curious about Indic linguistics, Sanskrit, Telugu, Malayalam, Kannadam. Likewise, we were like curious about the linguistic aspect, because no one from other country will do this sort of like a linguistic sort of, or something like poetic sort of research, right? It is our duty. We need to collect the data from collect and digitalize that, so that like any researchers can use and build some application top of that. So this particular trend, or this particular culture, is actually enabling the foundational models and actually accelerating the AI research. So we were talked more about like the story and the fundamentals of foundational models, and we are trying to understand what is the necessity, how it will help faculty. Because like if everyone joins today's session, everyone has their own motto, right? Like, okay, I need to learn this particular topic, or my college has opened for this particular, has started admitting students under AI. So if we have this sort of understanding, which is like very close to the industry's movement, it will be really helpful for us in the down the line. So, so another one thing is like in a foundation learning, the self-supervised learning is another emerging thing. So we all know different types of learnings. So supervised learning, we know. Supervised learning is nothing but I am a student, how I'm learning things with the help of teacher, because the teacher will always give me the feedback, okay, like changing my way of learning. This is what supervised learning. This is the key thing that everyone should learn. Everyone should know when we are like stepped into this particular domain. And another one is unsupervised learning, where a student is being led to explore by himself, and based on that he will have some rough idea about like particular content. And we already have like reinforced learning, which is like for every time I am being given with some reward. For example, if I just score 8.5, my college or my professor will give me some gift. So that gift, that reward is actually pushing me to learn properly, to achieve some heights, right? For example, if I get good feedback, or if I get good appreciation from today's FTP, this will move myself forward to do some sort of extra more and more interaction with the people, right? The same way, the reinforcement learning is completely dealt with reward process. That the term we called as Markov decision process or Markov reward process. You can explore about that. Then why do we need OSIP? So we discussed like we already have 3 different types of learning methodology. Then why do we need this self-supervised learning? The term self is nothing but the model, the architecture itself tries to supervise instead of waiting for someone, instead of waiting for some control from the outside to guide us. The model itself will start doing that. So, for example, in a normal task, we always need annotated data. For example, if we are doing some sort of sentiment analysis, the training data should have that annotations. Okay, this particular word, I am going to Chennai. So this is going to be a neutral sentence. I am hungry. Likewise, this is going to be a positive or negative. I'm so happy I have gotten a job in Amazon. So this is going to be positive sentence. So when we do some sort of like a self-supervised learning methodologies, we always dependent on annotated data, and annotated data, the data creation will take more time, because if it is a machine reading data, we can easily get it from sensors, or if it is like sales or business process related data, automatically it will be like recorded by someone, some entities present in the business process. Whereas applications like NLP or applications like computer vision, that has lot of that has like lot of scope, right? In the NLP, I can do question answer generation. In NLP, I can do hate speech detection. NLP, I can do ideology. Likewise, lot of things are there with the same set of input data. That is why we need this annotated data, and annotating data will take more time. That will require more money also. So that we cannot every time we cannot rely on that, right? The simple example for this annotated data is, as I said before, the ImageNet data set for image classification. And this image, the same way we have others also, COCO data sets, or Cityscape data set, like how we have this Titanic data set, right? Titanic data set is a structured one. But when it comes to like, and that is purely based on some field survey. The Titanic's data, or like Boston pricing data, that is being recorded somewhere electronically. Whereas this for data points for computer vision and NLP and all, we ourselves have to annotate them. I have an experience, like I have annotated nearly like 10,000 images, and each images will I've drawn like 5 to 7 bounding boxes in order to capture the particular, detect the particular object. So that is a tedious task. That is why to perform pre-training, because like pre-training involves larger number of data, like it will have like TBs of data. In such situation, we cannot hire people every time and make them to annotate the data points. That is why we are moving forward to perform the self-supervised learning. And also, it is not only for availability of the data, it is also like avoids overfitting. Whereas like when we just make the model to go self-supervised, automatically the amount of learning will have some penalty, because we don't have external factor to control, right? The model itself has to do that. That is why like we are including it. And yeah, one of the example is masked language model. This is one of the tasks which is like used to train BERT or any kind of NLP model. So masked language is nothing but if I want to translate and if I want to train one thing, like for example, a translation model, like I love you into some other language, or I am Prabhakaran into some other language, right? So in that situation, like we no need to give I am Prabhakaran into the model. We can just mask, we can just remove the in-between word I dash Prabhakaran, so that the model will tend to learn, okay, we have the word I, and what is more likely to come along with this word I. Or if we think in this, for example, here we have I like sprouts. So my target is, like, if I am given with like I as the word, the model has to predict the next word without any sort of like annotations. So that is what this like a self-supervised thing. Like if you just see in the, 1 second, I will take my annotations.
Sir, if you don't mind, I'll just make a small announcement.
Yes. So I was searching for this laser point. Yeah, madam, you can like give that announcement.
So there is a link called annotation. You can click on that. You will get some tools.
Yeah, actually, this is
Annotation is not, just go in more. There are 3 dots. I think it is not
Yeah.
there.
Yeah, it is.
Just a minute. It used to be there. I think it is
Yeah.
disabled or something like that.
Okay, 1 second. I will check it here. Yeah, I have the laser pointer from my. Okay, cool. So if we check, madam, like you are about to make
Yeah,
some
announce.
announcement.
Yeah.
Yeah.
So I would like to make an important announcement. The attendance and feedback link will be shared in the Zoom chat box only. Towards the end of the session, the attendance link will be shared and will remain active only for 15 minutes. No calls or messages in this regard will be entertained. Also, I would like all the YouTube live attendees to log into the Zoom meeting. And any queries or regarding any queries, please put the queries in the chat box. Thank you, sir. You may continue.
But I would like to add one thing here, that if we are saying the attendance link will be given at the end, so we have observed that 20-30 people only join at the end of the session. So we are going to check the Zoom attendance also, how much time the person has logged in. So then only we are going to take the attendance. So those who are willing to join only for attendance, I will really request them not to do so. Only those who are really attending the session will be given the attendance. Thank you.
Yes, madam. Thank you. So in the self-supervised learning, we used to train the model. Here we have taken this convolutional network. Whereas like we will take this unlabeled data, so that like it will try to learn the features irrespective of any kind of bias. So like once we learned that, once we like reached that some sort of pre-training without any kind of like labeled one, and we can transfer that knowledge. As I said, like the pre-training is the transfer learning is transferring that knowledge. We can use supervised downstream tasks, so that the model is data agnostic, or some sort of like bias agnostic. Like we have like unlabeled data, and it is concentrating everything, and it is trying to extract the features. It has the like learned parameters to do that. So after that, we are taking that and doing our downstream task. That is how all sort of like these foundation models work. I will show like how the self-supervised pre-training and the supervised downstream task work in terms of BERT model, which is our like core content for the day. And yeah, so in the foundation model, there will be one architecture and one trained model. Whereas like one architecture, one trained model, but multiple use cases. For example, a trained model, one particular architecture can be used for text related applications, image related applications, speech related or tabular column related, protein structure, organic. So a huge pre-trained model will help us in developing such things. Some sort of like not, so I'm not saying like all 7 will be taken care by one particular model, but few of them, like for example, text and image, sometimes tabular and protein related thing. I guess we can provide that versatility here. Like, yeah, and yes. So, for example, let's just imagine what kind of like applications, what kind of research we can do using the transformer based modeling. Transformer structure I will show, but from this foundation, like if I just have the foundation model, which is like pre-trained one, this pre-trained one you can get it from online. Like a lot of things are, a lot of resources are there. So for example, if you just take text, we are like in the academia, we can use it for like content creation, we can use it for like evaluation methodologies, we can use it for like collating things. For example, you are building some scraping, like web scraping engine, or you're doing some, you're building some Twitter scraping engine. So once we have the data, like the data will be like tons of data will be there, right? For example, if I just put some tag like engineering, or if I put some tag like data or AI, so with that particular hashtag, the scraping engine will scrap all the tweets. But by understanding what is being talked, what is being like discussed in that each and every tweets, we can easily segregate them. The same way, if you are doing some sort of research, you want to classify the abstracts, or you want to understand whether your area of interest is being discussed over there or not. So that's sort of like a research guy assistance can be given through the collation of transformer-based models and the text-based data. Text data is nothing but a set of abstracts, a set of research papers, a set of articles, right? I guess you can consider. And image, yeah. We know what kind of things we can do with an image. We can classify things, we can detect the objects, or we can estimate the pose, like how I'm standing, whether I am like bent my, what is that? Bent my spinal cord or not, or whether I'm sitting or standing, or whether I'm dancing or not. Like this, we can do a lot of things. There is a network called Bharadam Net, I guess, like that try to estimate the pose of all the Bharatanatyam poses. And there are some other networks are also there, which is helping to learn guitar. Like, okay, our finger position should be like this only. Likewise, like there are applications. And yeah, speech, we know automatic speech recognition, like how Siri and all doing. And you can build like domain specific. Like for example, if you want to build a chatbot or like voice assistant only for agriculture domain, which can be useful for like regional farmers, because everyone don't know Hindi, everyone don't know Marathi, everyone don't know Gujarati, right? So like we can build like a local language, so that people directly, okay, my crop has like yellow dots and it is like there is some problems. Likewise, we can talk to that bot. That bot will understand what are we talking, and that will try to give the solution, right? But it all depends on the architecture and the data collection that we are concentrating. And tabular, we know the reason, like we can build a number of applications using the table. It is like a very conventional one only. And protein, organic things and all like emerging, like a lot of investments are being happening over there. Even you can Google about like Google AlphaFold 2, which is like a kind of breakthrough in drug discovery industry that has been solved by the transformer based architecture only, where like this protein sequences can be protein structure can be predicted using using amino acid sequence as an input. For example, the huge problem in viral disease drug discovery is to understand the spike protein structure. If we know the spike protein structure, then only we can create the counter protein, so that that protein or that antibody will work against the spike protein of the viral, like a COVID, coronavirus, or like SARS, any kind of virus. But the thing is, we were not able to do that quickly, because in the conventional methodology, or else in the biopharmaceutical methodology, it will take more time, because that's some sort of like iterative based one. That is why like Google has come up with the solution, which is based on the transfer model. When we just give the amino acid sequence, like guanine, thymine, acid, like there will be like n number of sequence, like that amino acid sequences. When we give that sequence, it will automatically predict the 3D structure of the protein. This is one of the huge thing that happened. And last like 2 days back only, it has published in Nature in hard paperback copy, not online. It has released already, like the month of like July itself, and they published the results last year 2020 itself. So it's a step-by-step process. But yesterday or day before yesterday, they published in the paperback journal itself. And the organic chemistry, with the knowledge that we gained in the chemistry, process control and all, we can easily do like kind of whatever things we are doing in drug discovery, the same thing we can do that in material discovery, like doing some discovering some composite materials. So that like composite materials are like combination of two or three materials, so that we can end up in getting a new characteristics, new product. That new product might be like temperature resistant, or that may be like a cold resistance, or that is like infectant resistant, like that. It can possess any kind of properties. So that is one thing, like in organic chemistry or like material science and all. And the RL is reinforcement learning. In robotics, it's a major thing. The reinforcement learning can play chess with us, can play AlphaGo with us, can play some sort of like games also, right? So that is also possible with this. So these are all like actual application area of one architecture, but multiple use cases. So we were talking about, okay, we are training it and we are doing some sort of a foundation modeling. Like what is actually happening? In simple words, we are collecting like multiple the data from multiple resources and building the foundational, and that foundation model can be used for question answering, sentiment analysis, or extracting the information, or image captioning. For example, you can see this image captioning in a few of the Microsoft applications, I guess. When you just put deck, if you can check it in your PPT itself. If you just put one particular image, that the machine automatically will create the alternative text. Okay, it has cat. How it is happening? Because like it is understanding what is present in the image, and it is relating that feature with the language, image to language, vision to language mapping. And object recognition, we all know, like object recognition is the key for this particular self-driving or autonomous and all. And instruction following is with respect to the robotics or like autonomous systems. Based on the current scenario and based on the rewards that we are providing, the machine or the particular agent should follow that instruction so that we can end up in good position. So today we'll be mostly like considering this language and vision, which is like very easy, feasible for us, because that won't take much time to develop a particular project, and that is very impactful also. So the steps involved in this one is, as we said, the data has to be created, the data has to be curated. So like we can collect the data from n number of resources, and n number of resources, and that has to be curated, obviously. And once we curated, only we can train. And once we pre-train the things, we can go with the adoption. Adoption is nothing but the downstream task. And then there should be one thing concentrated, which is deployment. Because there is a saying like 80 or 75% of machine learning models are not being deployed. And they are undervalued, they are not creating any business impact. So to create such business impact, to create such immediate near future solution, we are stressing on this foundation models, because like we already covered this particular training part, so that our job is like adapt to domain specific application and deploy it so that people can easily started using that. So as a data scientist, our aspirants of artificial intelligence are machine learning guys, professionals. We always try to create the impact as soon as possible. As soon as, even if it is 2 years, that is sooner than 5 years, being 5 years or 6 years, right? So that should be there. And adoption, it is not only adoption of the pre-trained model, it is also adoption of new technologies. Because if Jagannath Institute of International Management School or ICT Academy didn't host this kind of sessions, at least few of us would have lost the opportunity of getting know about this trending things, this kind of methodologies, right? Same way we need to adapt. So okay, so far we have talked about why do we need foundation, what are the different applications of that. But I was continuously saying foundation modeling is nothing but a transformer based architecture at the end of the day, mostly. So we have convolutional neural network architecture also, but the wide range of application is not being covered in just a convolutional neural network. For example, if you have a pre-trained convolutional neural network, which is ResNet 50 or ResNet 151, Inception or XNet and all, you can do only one activity, which is image classification. You cannot do anything else. Or at the end, you can do extra one thing, which is object recognition or sort of representation learning, because that is not a wide range of applications, right? Whereas here in transformer-based applications, you can use one single architecture for image captioning, on the same architecture for visual question answering. Visual question answering is it's exciting application area where you can go just to give the visual. For example, the visual has two people walking with the bag. The visual question answering would be you are sending the query, how many people are going. So our model will understand our language. Okay, this guy is asking about people, and this people is about how many, it's a quantitative. So these two terms will be connected to our image understanding. Okay, he's asked about how many. Okay, let's see how many is related to how many objects. So two people are there. What are they wearing? They have t-shirts. What is the what is the color of the t-shirt? Red and blue. Likewise, this understanding is there, right? That will not be directly carried through just a convolutional network. That is why this transformer plays a major role, because of the versatility of the transformer and multi functionalities. So here we have transformer is all we need, because once we have the understanding about transformer and BERT and all, you can directly jump into any sort of literature survey and start building things. So in simple word, transformer is also a neural network architecture only. So it is not a big thing, because we all know deep learning, what is happening and what are the important things on that. So transformer is also a neural network model, but it has two things inside that. It has an encoder and a decoder. So a simple application of transformer would be, just to understand easily, machine translation. So nothing but we are giving some input. So that input has to be translated. For example, here J shows Eduant, which is a German sentence, which has to be translated into English. I am a student. Or if it is translated into Japanese, that should do. So how this translation is done, how, because in normal machine learning or normal even in a convolutional neural network in normal machine learning, we won't do this generation, sequence generation. Okay, I've given one sequence that is being generated in a different way. So there we need to enable the understanding, because if you take the language like Hindi, Tamil and all, the words will not be structured, or the words will not be directly mapped to English. For example, if I say I'm going to school, the word structure, that order of the words and its meanings will not be same in the other languages like Tamil or Telugu, Kannada, like any languages. Why? Because each and every language has its own linguistic, its own its own sort of like customs. So in that situation, we need to try to understand and try to map that, which means try to give the importance. Okay, we cannot directly go one by one. For example, let's imagine this choose is something different. It is not am, it is I, and the G is A. We cannot directly map, okay, G is I and choose is am. We cannot do that. We need to understand it in the contextual manner instead of just a position wise. Instead of just doing one-on-one relation, it should be like context based one, or it should be like how to say attention based one, because we are giving the attention to the correct word instead of just giving considering the location, right? So transformer is the like it has two blocks, and one block is encoder. The name suggests, as name suggests, the encoder will try to understand what is being given in the given input, and decoder is nothing but it will try to translate into the another latent space. So one latent space or one distribution space is in English, and that is being understood by the encoder, and that is try to extract only the features. I don't want the exact words, I want the essence of it. So from the essence, the decoders are trying to, okay, this seems to be like this, this features are looking like this particular way, so ideally we would select this particular way. Likewise, the decoders are taking that final decisions. This is how this translation works. Encoder do this extraction, and decoder tries to understand it and translate into a respective thing, right? And I'm saying like this encoder, previously we saw a transformer where we call the transformer as a foundational learning, and we come here, okay, we were talking about foundational modeling and foundation modeling, and the foundation modeling is more or less includes transformer based on only. Right now we are like discussing, okay, we have transformer. I've said like transformer has encoder and decoder, but we don't know like what is exactly present inside the encoder and decoder, right? Then only we can understand like how it is like different from other normal convolutional neural network or other normal machine learning or a conventional deep learning people also, because that is not being done. It's simply like the encoder like and the decoder, like there is something behind the screen. Let's see what is actually behind the screen. So for example, if I see this encoders block, so encoders block will have like multiple encoders, like how we have this artificial neural network or in a deep learning. We just consider one particular network like ResNet 50 layers will be there, 50 convolutional layers will be there. I can say, okay, with a just a convolutional network, one particular layer, I can do sort of thing. It won't happen anywhere. The learning should happen in multiple stages. Then only like we can filter important things at every stage, right? The same way, encoders block will have like n number of encoder blocks. Each and every block will have two things. One is a self-attention. As I said, instead of doing a one-on-one mapping, we are trying to understand the one-word relationship to the another word, like how strong is related with each other. For example, I have a I have a sentence. I am Prabhakaran. Sorry. For example, meet Mr. Prabhakaran. He is working in New Sigma. So I need to understand the relationship, or I need to understand the structure of the sentence, right? Because what does it represent by he? I cannot, if I check just the meaning, or if I just check the output for he, I might end up in somewhere. But actually, we need to concentrate on, okay, he should be concentrated on Prabhakaran. My dog name is Ajay, or my dog name is Ramesh. It always like to eat chicken. So this word eat is representing the dog. So that attention has to be there. That is why we are using the self-attention. Self-attention is nothing but attention on the data itself, instead of attention to the another one. Like, for example, instead of connecting one sentence to another sentence, we are trying to understand the linguistic alignment of the sentence itself. That is why we are doing the self-attention. So in the architecture, we could see like one encoder will have self attention, and it will have like it will have the feed forward. Feed forward, we know, right? Like this is the new this feed forward architecture is the first architecture everyone should learn in deep learning. It will have like n number of hidden layers, and it will do some sort of weight learning, like weights and bias parameter learning. So we have self attention for input, and we have self attention for output. But how will I connect both of them? Like how we are doing this, right? Trying to connect. That is where we are using this encoder to decoder attention, where each and every input will be tried to map with the output, possible output. For example, I might be phonetically wrong in pronunciation Hindi. Kindly bear me that. I have a word, Mera naam Prabhakaran. Hi. My name is Prabhakaran. So we need to map this, right? Mera to some other word. My. Naam to name. And Prabhakaran to. So this should not be happen explicitly position wise. It should be happen. Okay. Here Mera is something related to addressing a particular person, or like self-addressing, my. So these two words should be like interrelated. These two words should be like given attention from each other. Mutual attention should be there. That is why we are using this encoder to decoder, which means like relating the input to the output. And we already have this feed forward to perform the additional computation. So likewise, if you consider these blocks one by one, and if you are using it for not only for text related things, even if you use it for like image related things, that is what foundation. Because if I just have the multiple understanding about the text data, I can use it for wherever I'm using text, right? For example, if the model has learned more about the law, which is legal terms, so that this can be used for, okay, if you just ask what is IPC section 303, the model will understand, okay, this guy is asking about 303. What is that 303? That is IPC. So relate this IPC 303 to some content, attempt to murder or like attempt to haste. Likewise, like this relationship will be enabled, right? So the detailed architecture will be like this. So self-attention, we've seen this self-attention will be there, and there will be like normalization, because every time we need to perform normalization, because like we are handling with more data. So in that situation, like more data should not lead to like bloating values or like exploding values. That is why we are every time like normalizing things. And feed forward. So self-attention, normalize. Feed forward, normalize. Like this, we have multiple things. So once we have this encoded version, here I have the encoded version. That encoded version will be used here. You can see this encoder decoder attention, which means whatever features that I have understand, that will be compared with the whatever output that we have. So that like this relationship would be like connected with it. So this is the encoder part. So here we have two encoders, 1 and 2 stacked on top of that. And here we have two decoders. And we have another linear layer and softmax layer. Why do we need the extra layers? As in, like, we just consider the encoder and decoder part, it will be still remained as some sort of like model, but that model is a generic one that is not being devoted to one particular task. That is why we are going around this linear and the softmax. We know why do we need softmax. Softmax is to perform multi-class classification, right? For example, if you want to classify each and every word into some other language word, for example, if I use like I, so that I has to be like translated into some Tamil word or some Malayalam word or something else, right? So likewise, like for each and every token, so we used to call this as a tokens, like some words as a token. So that has to be done on each and everything. Or else, like, let's imagine you are giving some sentence feed, some 1, 2, or 3 lines. That has to be classified into hate speech or not, offensive speech or not. You could have imagined like during the US elections, like Twitter automatically removes Donald Trump's thing. Or else even if you go and talk about like COVID, it will try to like say it is COVID exclusive information. Likewise, it will auto tag it. It's not only for Twitter, also in Instagram also. How does it happen? Because it is trying to understand what you have written and trying to equate each and every word inside that to the relevant topic, that attention topic. How close are they? That is how it's working. Like for example, this is how the attention will work. For example, I have a sentence. It is self-attention only. It's not encoded decoded attention. So the animal didn't cross the street because it was too tired, right? So we need to understand the attention, which is like the relationship between each and every word with another word, so that only if at all like we have a question and answering kind of job, or if we have like a question generation job, we cannot just go with okay, replace dog with what, replace D with Y. Like we cannot do that. You need to understand like what is being discussed. That is why, for example, the animal, what is it representing? The animal. So it is actually so let's go in this way. Like, let's take word it. So the it has to be connected with something, right? The it is highly connected with the animal. Obviously, like it means some pronoun. So that pronoun is pointing out the animal, the noun, the animal. So likewise, if I take the animal, automatically the attention will be given to it, and might be like cross and okay. If I just take street, it will be like cross will be the attention, because like where are we? We are on the street. What are we doing? We are trying to cross. Likewise, like the relationship, like the neighborhood will be defined through this self-attention. You can try to build your own attention network. So based on that, you can see, okay, when you are talking about like tennis, like will it be like I am planning tennis, I would love to learn tennis, but no one is helping. So likewise, this can be checked for any kind of input, whether the attention is working fine or not. This is like all these things are like try to infuse that context-based learning instead of just position, or instead of just randomly black box methodology. The self-attention is enabling whatever I'm learning, there should be some cause. That is what like the power of self-attention. And right now, everywhere this attention is there. Even if you take time series analysis is using attention. If you take GANs, image generation networks are using attention. Why? Because like they understand the power of this attention network, which is like, okay, it is explicitly saying, okay, this is what impacting this particular problem. And this is how sentences are being mapped together. So if you understand that, we can use it for the future scope of research. So, okay, transformer is all we need. We understand like we just saw like what is happening and what is inside the GAN, like how it is. Like I didn't put any mathematical thing because like I don't want to make people diverted in the day one itself. I just wanted to bring things first, then based on your interest, based on your expertise, you can go ahead with like, okay, let's go into mathematics further, and then we can do sort of things. Right? Since it is like a very sort of very beginner level of thing that we're talking, I didn't mention that, any extra diverting topics. So this is like architecture. So it's a simple, like the same thing only, but a simple representation. You can see that. So you could see one thing. So for each and every token, all the other tokens also being considered. So it is not a sequential process. At the same time, we can pass all the tokens. For example, if you consider RNN-based modeling, so RNN processing will be like, first it will take one word and will do the processing, and from the output of the word, it will do the another processing. So it is not happening in this transfer encoder architecture, because at the same time, each and every token is dependent on all the other tokens. But we need to consider like how we are doing it here, right? For each and every token, we have this attention values. The same way, for each and every token, we are doing this connection, so that we no need to worry about this. Okay, this is our day, we need to do that. It's like we don't need to consider like this is going to happen in parallel, going to happen in like one by one. The beauty of encoder or beauty of transformer is like one time, and it will read from the both the sides. For example, if you take this token is considering the previous words and also the upcoming words, so that we are trying to collate things from the both the ends. For example, if you take it, this it can be related from the beginning, and also it can be related from the end. That's how things were working, right? But whereas if you just take LSTM or RNN, that both bidirectional things won't be available in RNN and LSTM. We have bidirectional LSTM that is there, but that is not a pre-trained one, right? That cannot be used for functionalities, multiple functionalities. That is what I'm trying to say. This is like a few features of a transformer network, and people had come and they just to take encoder and stack on that, name that as a BERT, and another set of people come and they took decoders and they stack it on one by one, and they just like 22 like some good performance from that, right? So this is how like transformers are actually being constructed and being used for the task. For example, you just understand like, okay, instead of this tokens, we can just give the image patches, so that like the image will understood. Okay, this is what present over there. If I just ask another query, it will try to map, okay, image to the sentence. For example, what is in the picture? So this what will try to correlate with the important feature, which is dog. Likewise, we can perform with the use of transformer. That is why we always need transformer. So yeah, as I said before, like we collect multimodal data. We need multimodal because we can do n number of things with the one particular thing. For example, like one architecture, but multiple different types of data, text data, images, structured data, so that we can do visual question answering. That is one thing. Like it's a cross learning, or sort of like a, how to say, some a multi-model, because multiple types are there, right? Like text, image, video, audio, like there's multiple things. So we wanted to collate. So when we're doing like visual question answering, or when we are doing some sort of like a visual image search, for example, in a visual image search in like Pinterest and all, we used to do that, right? Or even Google Lens, you would have known that Google Lens will, if you take some simple image, it will try to extract the feature out of it, and that will search for the related text. Okay, this is the YouTube channel, or this is the institute which has talked about myself. Like this, we can perform that multi-modeling, like getting the benefit from both the data sets, text and image. But it will require more knowledge in NLP and convolutional network as well. So that is why like we were stressing on multimodal things. And in the foundational model, there will be an expressive network, which is like there will be a like a network, which is an architecture will be there. And you can ask, okay, we have network, I will just train. It is not sufficient. We need to scale that, because whatever downstream task that we are doing, that should be like financially impactful, right? That is why like we are sort of like considering that scalability also. And with the help of this, what is that like? With the help of with the help of governor GPUs, like graphical processing units, we can scale this up. And compositional representation, which is like building blocks. What makes our model to proceed with this particular output? For example, if our model is like classifying the image into cat, what makes this model to classify this image as cat? That explainability is also should be there. It's one of the like key terms should be there. And once we train the model, we can store it anywhere, like as an embeddings or as a graphs, as a tables. Like this, we can store it anywhere. And embeddings are the great thing, like one of the major thing to perform this representation or like distance-based learning. A lot of things can be used to it. And graphs are emerging things. So whatever that we have discussed today, like so far, for example, I've discussed a transformer. So you can build a transformer with the help of graph neural networks. Because like graph neural network in the last 1 year, like from the end of the last year, like October, November, and all, this terms like again started emerging, like started like getting limelight. That is why I'm stressing on graphs also. If you have some time, you can try to learn about the graph neural network and all. And another one, so this is how like we have done with this pre-training. So always like pre-training as like that has to be updated only until we reach the good results. And once we trained that, what we can do is we can specialize one particular task. For example, you can specialize for one particular classification or one particular image related task. It could be like question answering, as I said. The questions would be like who discovered, it should be changed, who discovered the penicillin. Penicillin is like some sort of like fungi based vaccine or something, right? Injection. So that should answer Alexander Fleming. So the data should be like articles. The data should be Wikipedia articles. Then only the model will understand, like model will have that memory, right? Okay, we learned about Alexander Fleming. We thought that, okay, he was a pharmacist or he was like some research scientist. He formed the penicillin and that helped a lot of people come out from some sickness. So likewise, we can do this question answering and like it's like emerging. And another one is image caption. We can define our task after once we like just blatantly surrogately like we trained our model. We can define our code completion. Like we know this GPT-3 or Copilot, GitHub Copilot, and suddenly yesterday, we got like Codex, where if you just write like I want to, for example, I want top 5 features of the data set. It will do the query. It will write the query. It will complete the query. That Google AI programmer or Codex platforms and all helping in that aspect. So this is like task specialization. But another one duty for us is to like prevent from the model patching, which is like to give the external feedback also. For example, we have like we are trying to understand the different results of the model and trying to give the feedback. For example, UK is a member of EU, so this is one of the sentence, and the model has to predict like whether this is true or not. What if the model predicts true, which is wrong, which is actually like UK is not part of European Union, right? So it has to be corrected. That is what the model patching. That continuous learning should involve this model patching also as we go ahead. And temporal adaptation, it's nothing but like updating the data. For example, if we collect the for example, if we collect a logo classification model in order to understand like what is being put in websites, like kind of, right? So in that thing, after sometimes a company might have changed their logos, or if you are doing like a news article classification, after sometimes people would have forgotten like particular journals or particular news. That is why that has to be updated in a temporal manner, which is like updated based on the some time span. Okay, let's update for every 1 week, every 3 weeks, like this. So that this is how we are handling this downstream task once we have this pre-trained one. So this is like very few things we have discussed. There are n number of things you can explore by yourself with the help of the learnings that you have gotten today. So we come up to the BERT. So 1 second. I'll have some water. Okay, so far we discussed like explicitly about like, okay, transformer. I hope like people will have an idea like what is actually happening in transformer, how transformer is using the self-attention, and how does it helpful for us in like doing this sort of like foundation modeling, because any type of model or any type of input can be interrelated with the help of attention. That is why like we are going around. So BERT is nothing but we all know this particular cartoon, right? This angry cartoon. This particular cartoon image is what? BERT. But the explanation for BERT is bidirectional. Bidirectional as in like the model will learn from the both the sides. Both the sides as in like from the end of the sentence and from the beginning of the sentence. That is why we are using this as bidirectional encoding representations, which means since why are we saying this as an encoding representation? This is a pre-trained model. This representations can be used for any kind of like applications. That is why we are saying this encoding representation. This is coming out from the encoder only, not a decoder, from the transformers. So if you see the architecture, you won't see the place for decoders. We are just using the encoder architecture. That is why like the encoding representation is placed in the BERT. So the encoder cell will always try to understand the input sentence, and it will try to decode using like sort of like feed forward network we have, and we have this self-attention layer. So that like from by word, it will try to understand the relationship. And that is not from one end to another end. It will be like both the ends, like bi-directional way. At the same time, it will be. And yeah, that's why like that is a major part of pre-training update, because like it will use the input words simultaneously. Like if you give like 512 words, it will automatically take it at the same, instead of like going one by one. Okay, just give one word. Okay, I and give the next one like bless. Likewise, it is not like one by one and waiting for others to go. It's going to be like, okay, you know the basic understanding about basic structural understanding about BERT, and you know what BERT can do. Let's go ahead with like the history. That's how like we come. So the training of so we are saying like, okay, BERT is just having like encoding encoding structure which won't have any decoders. But how are we actually training it, pre-training it? So there is two aspects. Like as I said before, we always like consider on a semi-supervised or self-supervised based training, where we will not have like complete data in place. Whereas with the just available data, like we will insist or we will push the data to be like unlabeled in some places. That is the beauty of like the semi-supervised machine learning on larger amount. So the data set for this particular pre-training will be collected from like multiple places, from the villages, from the from data sets like online portals, online articles. So like from the lakhs of articles, like thousands of articles, we are forming the corpus. So from that corpus, we are just training it for the surrogate task, like as in like the generic one. So once we performed that, self-supervised form, semi-supervised form, right? So we can do with the supervised training, which means we can take this trained one and we can use it for our own use case. For example, buy the pills, win which prizes. Likewise, like we will be having input data, and we will perform this downstream. Like you can see this extra head on top of that, extra extension, like classifier extension. So that will classify like, okay, whether the given things are like spam or not. Right? So these are the steps in like training. Like first step is like semi-supervised one, which means just like I will discuss like what will happen in that. That is like in that process, like there will be like a lot of food, there will be a lot of data points, and using that data points, like we are training for a common purpose. And once we train that, we are taking that up and trying to fit it for one particular application. For example, one model, but the application is different, which is to classify the sentence, automobile industry sentence. which is like buy the splints, win cash prizes. Yeah, like this. Yeah, this is how things are happening around BERT. But what is the pre-trained? So pre-trained, as I said, like there are two methodologies. One is masked language, and another one is like next sentence prediction. This is what like the semi-supervised one. Right? When we mask some email, like for example, if I give some one sentence to the training, I can mask in between sentences so that like the learning will happen in the both ends as well as like contextual manner. Instead of like memorizing the positions, if you just cut down some spaces, cut down some sentence words with the mask, which is like some wrapper on top of that, we can do the understanding. Okay, from the both the ends, and we can relate with each other. That's what like masked language modeling when it comes to pre-trained one. And the details about pre-trained one is like the large corpus. This is an unlabeled text, unlabeled. It is not like a labeled one because like that will take more time, right? And the entire Wikipedia, like 2,500 million words are there. And book corpus, the book corpus can have anything like the Vivillium, or it can have like Shakespeare's story, or it can have Mastro's compositions. I guess like that can have anything. So by combining both of them, by performing like the masked language prediction and next sentence prediction. So masked language, as I said, we can remove some sentences, some words in between that, and make our model to learn, model to predict, so that the model will understand. Okay, co-occurrence of words. Okay, if I just give I and you, obviously like the words that can be possibly come across, come along with the I and you will be like you, love you, or hate you. Like this, few some sort of like attention can be given, right? So that is what like in masked language happens. And this next sentence prediction is nothing but so for example, when we are dealing with the images or videos or even like sentences, one timestamp will not cover all the contextual relationship. For example, whatever you have written in the previous paragraph will be related to the concept that we are discussing right. So this particular next sentence prediction is nothing but to relate one sentence to its next sentence, so that like okay, we will have some peer connections, and will understanding like how things are connected, like how sentences are connected with each other. That is important. That is why like we do this next sentence prediction also, which means like we will give two sentences. We need to say whether the sentence A is the next sentence of B. So the model will try to, okay, sentence A has something and sentence B has something, whether both of them relatable or not. Using like self-attention mechanism, it will try to understand. So that's how like models are being trained, especially this BERT model. And I have given like how inputs are being given. Like it will have the token embedding, which means for each and every word, it will have a token embedding, and it will have sentence embedding. Why? Because we need to perform this, right? Like we need to perform this next sentence prediction. That is why we are giving like sentence embedding also for each and every sentence, the sentence embedding and positional embedding. The major thing and major update here in position embedding is to point out where this is particularly located, whether it is in the end of the discussion or whether it is like available in the beginning of the discussion. So that is why we are using this positional embedding. So 3 embeddings that will be connected together, and that will be fed into a transformer encoder, which is like stacked transformer architecture, which is like 12 or 13 architecture layers. And that particular machine or model will be suggested to go with this BERT understanding. So these are the main number of different downstream ones. As we see here, okay, we can do this pre-trained one. But what else? What next? So the next is different times, like different downstream tasks. The one is sentence pair classification, which means whether both sentences are relatable or not. What kind of sentences, whether it is reason and question. Like this, we can do the sentence pair classification. And a BERT for single sentence classification, which means like hate speech detection or sort of like sentence classification, sentiment classification. Like this, we can use this. So yeah, if you keenly look into that, you can see where we are getting the output. We are not imposing anything else. We're not putting any stickers on top of it. We are just explicitly mentioning like what is required for people. And the next one is next sentence pair classification task. And we have like, sorry, it just copied another one. So question answering task we can do. And we can perform like sentence tagging, which means like NER. For example, named entity tagging. You are working for a banking sector. In the banking sector, there will be some roles. Okay, we need to each and every word, it has to be like classified. It's a sort of like a POS tagging, point of speech, parts of speech tagging, right? Like when I say like I'm not Tamilian, or I'm not a data scientist. Like what is I? I is a pronoun, and data scientist. It's going to be like an object or adjective. Like it will be something else. Likewise, like each and every word in a sentence has to be classified instead of classifying the whole sentence as the whole. So for to get more insights about that, you can follow my like a web page where I will give like more insights on that. So these are the downstream tasks. So as I said, like BERT is the like foundation. With the BERT foundation, we can build n number of different variants. That is what we are seeing. Like as I said, BERT is a famous American cartoon. So with the help of that BERT architecture, with the help of that BERT core idea, both like multitasking and sort of like mask language modeling and sort of next sentence prediction. Like this, based on the task, we have multiple varieties like Roberta, MLNet, Ernie, VideoBERT. VideoBERT is for like cross modeling things like understanding the video and question answering, and word embedding for like a whole word list in the word. Likewise, like there are a lot of varieties of BERT architecture. So that is what like foundation, right? We have BERT foundation. On top of that BERT foundation, we could able to like build a number of NLP centric also we are doing. So when we are talking about like when we talk about that BERT, and we are seeing like different varieties are there, Ernie, ExcelNet, or like we have Roberta, Albert, and all that. It is like based on like the situation we are building new variants. But what is the capability? The capability of BERT foundation model is like the major one thing is like whenever we are talking about the machine translation, NLP, the first thing is like multilingual translation. Which means I want to translate Tamil into Japanese. So far, we are using this thing, Tamil to English, English to Japanese. Likewise, there is. So, but with the help of proper training, one-on-one training, we could end up in like a multilingual translation, Tamil to Malayalam, Tamil to English, Tamil to Hindi, or Hindi to Tamil. Like this we can do. And another one thing is automatic speech recognition. So it is not like just understanding the tone and directly writing, okay, it is like in this pitch, so it should be like pronunciated as A. It is not again. It comes with practice and like automatic speech recognition, like kind of like locker systems, security systems, and all people are using. And sentiment, hate speech, text classification. It's like a very simple term, and it's very like foundational. And we can use it in chatbots, and we can use it like sentence tailing and spell checking, grammar check. It is like it's like a emerging product idea. This grammar-based spell checking. For example, I'm not like I'm not sound in communication, or I'm not sound in like English writing. So that if I use this BERT model or like a foundation model, if I like tune for my own purpose, the sentence can be styled in a like in a Western way, and I can check the spells, or I can the model can easily iterate over there, and it will try to find the errors like grammar check. It will try to figure it out. Okay, this is how the linguistics says, and this is how the model should follow. Likewise, we can do. And question answering and question generation. So question generation is a wonderful idea for people those who are in academia. Why? Because like you can start your own startup. You just because of the ability in BERT and deep learning, so that you can use the question generation and automatic evaluation, so that like people can be evaluated in much more easier manner. And named entity recognition, as I said, like most of the research paper will dealing with this named entity recognition, because like they want to understand like what kind of words are being discussed over there, keywords are being discussed over there, and they want to talk of like they want to like figure who is who. For example, like if you are the customer, okay, you have some excitement to do that, everything. But few times like we were not able to find customer symptoms. So that is why we came back and like give the okay, let's be close to the application like named entity recognition and summarization in one of the another thing. Like if we give like 10 pages of paragraph, we would need to like kind of like summarize that. Like how the inserts and all doing, right? Like the inserts will have more details. Like some other companies would have given details, and inserts directly like copy pasting it, saying okay, I am cooking some summarization task. Like this we can do. So the capabilities of BERT foundation models, like with respect to vision, we have like a lot of things like path planning, like object detection, self-driving car. Like this, we have multiple things to do. In the same meanwhile, like with the respect, like with the application of uh, uh, vision transform, like a vision BERT models, we can do image classification, we can do object detection, what is the object, and we can estimate the key points and poses. Like key points predictions are pretty much helpful in activity based applications like sports monitoring, like to understand the movements of the users, so that like you guys can improve your skill set in playing, right? So that will be helpful. And visual question answering, we know that, and instant segmentation, multi-modeling training, and image and content-based filtering. For example, like image and content-based filtering is nothing but like one sort of like lens also, Google Lens also. Like if you're, so you can, like for example, if you just take the picture, the search engine will like try to map the image to existing content. And text detection in OCR, once we like detect all the text in there, and we are saying like we don't have any relationship between that. But the thing is like GANs are wonderful invention in the year 20, like in the 21st century. So that is why I asked like what is the status of this one. Yeah, we are able to run it. The thing is like I will try to like put it over there where I couldn't find time. So I've taken two major application area. One is healthcare and another one is education. So in healthcare, like there are a lot of places where we can concentrate on drug discovery, on patient monitoring, or on like health record monitoring, or profiling the symptoms and giving the personalized medicine. I guess a lot of healthcare related things we can do, and biomedical as in like personalized medicine, or like prognosing or diagnosing the test results and clinical trials and all we can do. So there will be a number of data points. Like it's not only going to be the invoice or like just Google data. There will be a lot of data sources, right? The data can come from like a Salesforce post portal. Data can come from like sort of like any number of things, right? So that is why like we need to build this foundation model, and then we can scale it up. And the same way in education also, automatic question generation or like automatic programming guideline are easy to understand the equations intuitively. I guess a lot of things are there. And one humble request is like people can build actually like without any delay from college side. Likewise, we have discussed about the application capabilities of foundation models. We have like extra 15 minutes. I'm done now. Like if you have any queries, I would like to address them. So you can just post in the chat box. So I will try to answer. So we have like extra 10 minutes. So like the 10 minutes for question answering. Discussions. It's not like a monologue, finally discussion.
In case any participant wants to ask any questions, any queries, please share it in the chat box.
Yeah, one request is like we didn't cover math behind that, because like that that will take more time. So just to give the awareness, just to create motivation towards this foundation modeling based application development and research, like we started discussing about this. And a lot of other models is also there, like how I mentioned here, like DALI, CLIP, GPT-3 and all. But BERT is feasible one, because like GPT-3 is not available in open source, and the CLIP and DALI and all like have only restricted use cases in image generation and text generation, whereas BERT can be used for legal purposes. There is a GAN called Legal BERT. There is a BERT called BioBERT, and a lot of things are there. Yeah. Any questions? People like kindly ask so that like we can discuss.
Yes, sir. There's a question in the chat box, like, is there any difference between AI and ML, or both are same?
So the thing is, PhD is our end goal, right? But doing that research in artificial intelligence is one of the way to reach. The same way, our aim is to reach artificial intelligence, which means like we need to build a system which can mimic the human intelligence. That is our desired state. That is what we wanted to land on. But how can we land? Using machine learning, using deep learning. So AI is the destination. Deep learning or machine learning is the path towards that. So this is how like we can easily distinguish. One is a product and another one is the way to achieve that product, or the working principle of the product. Or one is AI is the destination and machine learning is the path to reach the destination. We can still, okay, AI can be like done, like built just using like rule-based things only, if-else rule or some other rule, fuzzy rules and all. But the thing is, that particular path, which is like explicit rule creation, that particular path is like distance of like the distance between moon and the earth. Whereas the machine learning or deep learning is the shortest route. That is why people are referring to it, using that. Yeah. Any question? Like I couldn't see any other question.
Yes, sir. It's there in the chat, like how we can use these in the teaching to make it innovative.
Okay, so we can build chatbots. We can build automatic question answering things. We can build like a common repository. As I said, like common repository, as in like you just like Google about knowledge graphs. That is emerging things also. For example, you can, yeah. So these kind of things can be used for teaching, like how we already have this. What is that? Like Copilot, where if I just give one set of sentence, that will automatically create the code. Likewise, if we just give one sort of like equation, the model can try to solve that. Or if you just give like some experiment, that will give the procedure. Likewise, like it is up to us. That is the main motto of this foundational model. Foundation is like we already have BERT, but let's bring this BERT to education. Let's bring this BERT to some education like related task, or like a medical or healthcare related task. That is the main motto of this discussion today. So obviously we can use it for education purpose. So we need to figure out where we pain points. Like as academic person, you need to list on, okay, this is the tedious one. For example, evaluation could be the tedious one. Like the people are taking more time in generating the question and giving it to the people, and they are taking the test and submitting it to the academy people, and they are like evaluating. What if like if we can evaluate, like automate everything? Like the model will generate the questions, and another one model will evaluate, okay, whether the question that you have written asked and the answer that we have written is like close to each other or not. Likewise, we can do. We can avoid that tedious process of creating question paper and sending it to people and waiting some time for doing what is that, like taking that particular part. Yeah, education can be used. Yeah, any
Yes.
other question?
Yes, so one question is like how the artificial intelligence can contribute here.
Here as in? Where?
Like, but just this is a question only, like how AI can contribute here.
So
the
whatever
question-
applications we have discussed, for example, in healthcare, we were talking about the diagnosis, prognosis, or clinical, like in education, like we were discussing about like automatic evaluation or question answer. Everything is our task. The transformer model itself is the like a part of artificial intelligence only. So artificial intelligence is not a code. It is not a programming language, or it is not a one particular algorithm. Artificial intelligence is our ultimate aim of humankind. Everyone is like pitching some new path to reach that. So if I say like a BERT, that is a way to reach that artificial intelligence, which means humans can only generate the questions, humans can only evaluate the question answers, whereas now transformers are mimicking that human intelligence as artificial intelligence, such a way transformers can itself create the questions and can itself evaluate them. That is how like we are reaching that AI. It's not a single algorithm. It is like the process that we are involved in. Yeah, any other question?
Yes, sir. Next question from Mr. Suresh. He's asking like which platform feasible for AI to teach for students?
Platform.
Platform.
Is he asking about a framework, Python frameworks, or platform as in like course framework, course platforms, like online web applications? Any
Maybe
reply from Mr. Okay. So
No,
I would
sir.
say, yeah, okay. So I will answer both of it. So to teach your students, two things are important.
Sir,
One
it's
is
mentioned now online web application.
okay. So I'm saying like to teach, there are like online sort of blogs are available, articles are available, where we can find explanation in an intuitive manner that you can directly get from them, and you can use it for your. That is one thing. And with the framework wise, you can get started with Keras, which is very easy to learn. And we always should know about mathematics. We always should have like mathematical foundation. That is there. Like from when you ask about like online thing, like Coursera will help to teach. Udemy has a lot of wonderful courses. You can take that app. Our Medium blogs will be helpful for people, those who are academic people, to understand the daily trends and to understand everything in an intuitive manner. It will cost the 999, which is 999 rupees for an year. Like I hope like everyone could afford that. So you can go with that. Yeah, any other question?
Yes, sir. Can we use a BRT in medical healthcare?
Yeah, obviously. So that's what like I have put this right.
Yeah.
So this healthcare, the application, like application of BERT Foundation Healthcare, like it is in like patient monitoring. It is for drug discovery, understanding the medical documents, for the personalized medicine. Like this, we can use. So you can Google about BioBERT. So BioBERT is nothing but like it will try to like do sort of analysis related to medical terms and biological terms using BERT architecture.
Hello?
Yes. Yeah.
Yes, sir. So next question from Mr. Tali Tariq, like, can you find any comprehensive guide to text summarization using deep learning in Python?
So using BERT, we can do. Using BERT, we can perform the text summarization, as I mentioned here. If you want to know about if you want, what is that, like sort of resource, you can reach huggingface.co, where you can find POCs for text summarization in Python. Huggingface.co will help to like in terms of finding that capability building part. Yeah, any other? Yeah.
Sir, they are asking for your mail ID for future references.
Yeah, so my website is there, like prabhakaran.chandran.com, PRABAKARAN, Chandran, CHANDRAN.com. there all the contact details are available, because yeah, that is one thing. And otherwise, you can follow my LinkedIn page, where I always, like, every day, or at least like frequently, as soon as possible, in each and every week, like 2 days in a week or 3 days in a week, I used to post content over there, so that will help you. Even you can connect with me through LinkedIn also. So Prabhakaran Chandran, if you just search Prabhakaran Chandran, you can find me out there.
Sir, next question is from the audience, like difference between UIMFIT and BERT.
Okay, so BERT is a sort of BERT is the transformer based model, right? Whereas this one, ULM-FIT, is it's a like universal pre-trained model. So that's not a model, but that's still a way to pre-train, like how to pre-train. So that is not having any sort of transformer architecture. It is for like pre-train language, building the language model, and using it for like downstream activities. ULM-FIT, that is universal language modeling and fine tuning. That is ULM-FIT. And BERT is like transformer architecture. BERT has a lot of things to do with.
Okay, sir. Sir, they are asking for your mail ID in the chat box. Can you provide the same?
Where should I put? Like, okay. Or you can visit my webpage, because there you will get more information. Directly, you can mail from there.
Sir, can I provide this email ID to all the participants here, or
Yes.
yeah.
It's
Yeah.
up to you. I'm open for anything.
Okay.
And any other questions, madam?
No further questions, but they are asking for the PPT also. Like,
Yeah, I'll share it in some time.
okay. Thank you, sir. Thanks.
Thanks, madam. Thank you.
Yes.
Thanks for the opportunity.
Yes. Kajol ma'am, you can proceed.
Thank you so much, sir, for a wonderful session. It was indeed very informative, and we really learned much about the topics. Thank you, sir.
Yeah. Thank you, madam. Thanks. Thanks for the institute, and thanks for Professor Meenakshi, madam, for accommodating me. Thanks a lot, madam. And yeah, it might be like quite exhaustive session, quite overwhelmed session in terms of informations. But the only intent that I had is like accelerating the like applied research and development in an efficient manner. That's why like I put in like I disclose these things, which might give you some sort of direction to proceed the R&D, or incorporating the AI and the real-time problems. Yeah, thanks. Thanks a lot for joining, and thanks for the HOD, head of the and other faculty members for accommodating me and providing me this wonderful opportunity. I'm really privileged, and I'm really happy. Yeah, thanks, madam. Thank you.
We are towards the end of the faculty development program on new age technologies for innovative solutions. Therefore, I would like to invite Dr. Harsha Ratnani, Associate Professor, JIMS Vasant Kunj, to propose the vote of thanks.
Thank you, Kajol ma'am. Prabhakaran sir, I wanted to ask you questions, but it seemed that it was very interesting, and many other participants were asking. So it was really, we are using a lot of research-based projects on AI, but the BERT Foundation model hardly is being used. So it's really a new topic. We'll definitely incorporate with our students in coming projects, which you have suggested in your last slide. I was just going through it. very interesting. So the emergence of AI, which everyone got to know, was very well covered. And rather, I would say, not at the faculty level, we can also use this research at the student level or a mass project for any government base, because lots of platforms are nowadays working on these kind of translations. So NLP, as you already said, the regional languages are yet to be explored.
Yeah.
So you were talking about Malayali. So there was one of our teams which were working on Tamil words, but it's very difficult to get
Yes.
the NLP. Yeah. So it's reverse order. I remember he was facing a lot of issue.
Yeah.
So I am very grateful to you that you have introduced this BERT Foundation model with all of us, and we'll definitely go ahead with the research on this.
Yeah.
With that, I would like to thank you from the bottom of our heart that you have taken time out. Yesterday, we missed your session and everybody was, looking forward. So you just made it today. That was so nice of you. With that,
I hope
I would.
I didn't disappoint anyone.
No, sir, we waited for you for 15
Because,
minutes and
yeah.
then, yeah.
Yeah. No. So
no,
the
no
thing is,
worries,
like,
sir. We
I
are all
got,
academician. We understand. Yeah.
yeah, I got my jab the day before yesterday. So I was like completely like I couldn't. I was bedridden kind of thing.
So we have wonderful audience. No one complains at Trust us. Like
Okay.
they all understood. They all really rather appreciated that you have taken time out to on the next day, very next day. That's very professional of you.
Yeah.
With that, we'll like to thank the whole ICT Academy sessions which were taken on day 1 by Mr. Mayur Bhushan, on day 2 by Mr. Ashwath Raj and Mr. Pankaj Mute from QLake. Then on day 3, Miss Ngok, NGO, and Miss Pratiksha Yashwant for business processing mining. Then on day 4, we had a very successful session by ICT Academy internal faculty, Mr. Siddiq Sharif, on securing cyberspace. So all these sessions were really very different from each other, and they, put forward the innovative ideas, which was the main motto of this faculty development program. We were looking forward for these kind of speakers only who can introduce these new topics to all the faculty, which they can take further. Okay, so that the motto was really met forward. So we look into conduct more such detailed sessions on especially technologies like RPA, which Mr. Mayur Bhushan has committed, and some sessions on business process mining, which the Celerio organization wanted to conduct. We'll look forward to conduct those sessions in future. With that, I would like to thank our respected chairman, sir, and director, sir, for motivating and guiding us through all these platforms where we can acquire new knowledge, new innovative ideas. I would like to thank Dr. Meenakshi Narula, our torchbearer or our leader who's there with us throughout this session, and who could bring forward all such this whole thing was done with her efforts only, because we were not able to get such good speakers. Ma'am has done so much of efforts to bring together all the 5 speakers from different arenas, so that it could be a hit show or it could be a very useful FPP for all the attendees. So really thank you, ma'am, for making all these efforts. We would like to thank all wonderful faculty who have joined us as a participant, and I'm sure they must have gained a lot of information from this FTP. All the 5 days were very different, very innovative technologies, which we have not heard and seen before. So they must have been, sharing their suggestions and feedback. So we would like to thank them for their feedbacks, and definitely we'll look into their suggestions. In the meanwhile, they can also keep in touch with our organizing committee for the future FDPs, or they can keep in touch with the ICT also for future FDPs, which we'll be conducting. So soon we'll be conducting our next FDP in winter session. Okay. The last but not the least, we cannot do this event without the efforts of our sincere efforts of our organizing team. So I would like to thank Dr. Shalu Tandon, Mr. Deepak Sharma, Dr. Anisha Tandon, Ms. Snehlata, Ms. Priyanka Ratan, Ms. Garima Seni, Ms. Kajol Rana, and our IT team members, Mr. Bhuvan and Mr. Devendra, for conducting this online FDP so smoothly and making it a successful, participating event. So thank you ICT team for giving us such wonderful speakers and making it a hit show. For all 5 days, we were actually glued to our systems, were not able to move here and there. So none of us missed any bite on this system. Thank you, sir. Thank you, ICT. Ma'am, over to you.
Yeah, before we conclude, I would like to say a big thank you to Mr. Prabhakaran from my side, because yesterday he was not well. Still, he has taken out the time, and he has prepared this. Actually, he was to deliver some basics of AI. Then I requested him that I think most of the faculties might be aware of, to take up something new. So I'm very thankful to him at such a short notice, and he was not well. He has recently got vaccinated. That's why he was not well. But still, he just prepared this session for all of us. So thank you, Prabhakaran sir. It was a great session. We have learned something new, BERT foundation model. And I would like to apologize to all the participants also for not conducting the session yesterday. It was all of a sudden, actually. In fact, we thought one Mr. Prabhakar from the participant had joined, so we thought he is the speaker. So after a few minutes, we realized that the speaker is not there. I contacted him, so he told I'm not well. So all of a sudden, we had to just abruptly terminate the session yesterday. And I'm really sorry for that. Actually, we were not informed. Actually, I think sir was not well, so ICT could not inform us. So thank you, sir. Anyways, you were able to make it today, and you have delivered the session, and all the faculties are there as participants. Definitely, they have learned, as Arsha has already mentioned. So thank you all of you for attending the the FDP for last 5, or no, today it has become 6 days. So please give your feedback, genuine feedback, so that we can improve for our future FDPs. And I hope you will be joining these sessions, these kind of FDPs in future also, when we will be organizing. Thank you, everyone. Yeah, Kajol, over to you.
Thank you, ma'am. And I would also like to thank all the participants for participating in the FDP. It was really our pleasure to have you all with us. The feedback and attendance link has been shared in the chat box, and we would disable this form by 12:30, right? And once the time is, will be ending the meeting. So please put your
yeah.
attendance and feedback.
Can we have a group photograph, ma'am, there? Kajal, ma'am,
Yeah,
can
yes.
yeah. So
I
I
would,
request, yeah.
Yeah, I would request all the participants to turn on their videos for a group photograph.
Prabhakar sir, can you remove your screens? Prabhakar sir, are you there? Yeah, thank you.
Thank you all. We'll be compiling the attendance of 5 days, and we will be issuing the certificates within a week's time. So please fill your attendance and the feedback. I would request all the participants to fill the attendance and the feedback. The links for the same are provided in the chat box. I would request all the participants to fill the attendance and the feedback. In case all the participants have filled the attendance and feedback, you can leave the meeting.